Bitwise operators in Java. Here in this demonstration we are discussing bitwise operators available in Java. So we have defined two variables, val1 and val2, with the values 12 and 10, and they are of the type of byte. So the binary representation of 12 in byte, that means in 8 bits we have written, and also the binary representation of 10 in 8 bits we have mentioned that one. So byte result, so we are defining another variable result here. So it has been represented as res. So result is equal to byte of not val1, that is a bitwise complement val1. So this is known as a not. Also the operator is known as tilde operator, and we are converting it to the byte type and assigning to this result. Now what is happening here? So this val1 is actually containing 12. That means there is a binary representation of 12. So 12 means 8 plus 4. That means at the 8 and 4 place we will be having 1, and rest bits will be filled up with zeros. So now to get that 1's complement of it, we are getting this one as 4 times 1 and then 0 0 1 1. So that is the not of val1. So if I print this one, we are getting here minus 13. Now question is coming in mind, why it is minus 13? Why the value has got printed as minus 13? We know that when the first bit is 1, then the number will be treated as a negative quantity, and to get the magnitude I should calculate its 2's complement. So 2's complement means 1's complement, that means zeros will be replaced by 1 and 1's will be replaced by 0 plus 1, and that is the 1's complement plus 1 will be the 2's complement, which will be denoting the magnitude part of the number, and the first bit will be denoting the sign, that is our negative, because the first bit is 1. So now what is this? This is our 12 plus 1, so that is a 13. So minus 13 will be the outcome, and that we are getting here as the outcome here. Next one is val1 and val2. So and here we are doing the bitwise AND operator, so it will be denoted by this ampersand. So now if we do the bitwise, just you can do for the columnar, just see. So here only we are having this 1 and 1. So that's why this place will produce 1 here, and rest all places will be producing 0. So this 1 means at the 8th place we are having 1. So if we print, we can find that after doing this ANDing, we are getting the 8 as the outcome. In case of OR, what is happening? If you go on ORing, bitwise if you go on ORing, you can find that it is 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, and the rest of the bits will be 0. So 1 1 1 0 will be the outcome. So that means 8 plus 4, 12 plus 2, that is the 14 here. So that's why after ORing we are getting this one as 14. Next we are going for this XOR operation. In case of XOR, it will be denoted by this upper caret, that is the operator, that is the XOR operation, bitwise XOR operation. So what will be the outcome? You know that in case of XOR operations, similar bits will produce the output 0, and dissimilar bits will produce the output 1. So here I will be getting 1, because 1 and 0 XOR is 1, and this 1 XOR 0. So 0 XOR 1 is 1. So rest of the bits will be producing 0 after XORing, bitwise XORing. So 1 1 0 will be the outcome. So I am expecting 6 as the result. Yes, we are getting 6 after doing the XORing. Next one is there is a shift 2 bits towards the left, that is a val1. So here we are having this val1. So I'm just shifting it towards the left for 2 bits place. So I'm just going for, so if I go for this 2 bit place, so it will be coming like this, that is towards the left. So these 2 bits will be off, will be lost, and 2 new bits will be coming to fill up the blank space. So we can find that it will be having the format like this, and which is nothing but, here it is nothing but 32 plus 16, and that should be 48. So we are expecting that the value will become 48 here. So now let me go for the execution. You can find that the value has become 48. Actually what is happening, the bit which is at the 8th place with the place value 8 has been transferred to the place value 32. The bit which was at the place value 4 has been transferred to the place value 16. So actually we are doing 2 to the power of 2 multiplication. Actually we are doing 4 multiplication, that means 2 to the power of 2 multiplication. What is 2 to the power of 2? This 2 is actually denoting that for how many bits we are shifting towards the left. That means if you shift towards the left for n number of bits, then the magnitude will get increased by the factor of 2 to the power of n. So that's why 12 into 2 to the power of 2, that means 12 into 4, so 48 will be the outcome. So that's why we are getting here 48 as outcome. Next one is that we are going for this value 1, which will be shifted towards the right and 2 bits towards the right. Then what will happen? So these 2 bits will be lost and extra 2 zeros will be coming up. So these 2 bits will produce 2 and 1. So that means I'm going to get here 3. So that's why we're getting the outcome as 3. So what is happening if we go for n bit right shift, then actually the number will be divided by 2 to the power of n. So here the value of n is equal to 2 because we are doing 2 bit shift. So 2 to the power of 2 is 4. So 12 by 4. So 3 will be the result here. So in this way we have explained the bitwise operators which are available in Java with proper demonstration and example.